Hello students. So today we will continue with exercise 3.2. Okay, question 17. So here you are given a matrix A and a identity matrix and you have to find K. So looking at the equation which is given, you will know that you have to substitute values of A square, A and I, and you can find the unknown, that is K. Okay, let's solve this. So first you find out A square. So A square is A into A multiplying, you will get row into column. So 3 3s are 9 minus 8, 3 2s are 6 plus 4, 12 minus 8 plus 4. Okay, so 9 minus 8 1 minus 2, 12 minus 8 4, this is minus 4. Okay, so this is your A square. Now you substitute A square in your equation. So A square K is some scalar minus 2i. So I'll multiply 2 inside, that is in identity matrix. So 2 0 0 2. Okay, so multiplying this K inside, okay, and taking this subtraction, that is doing difference, you have to take. So it will be 3k minus 2 minus 2k plus 0, 4k minus 0 and minus 2k minus 2. Okay, so now we have 4 equations, right? So you can choose any of the equation and you can find, because these matrices are given equal, each of these entries are equal. So you can take any of the equations and you will get the answer. So I'll take the easiest one, that is minus 2k equal to minus 2. Okay, so you'll get k equal to 1. Okay, let's solve the next question. Okay, this is based on trigonometric identities. So you should first revise your trigonometric identities which you have learned in your 11th standard. Okay, so let's solve this. If A matrix is given like this and you have to find, you have to show that this I plus A, I is identity matrix, I plus A equal to I minus A multiplied to this matrix. Okay, so I'll start with RHS. Okay, so I minus A is given. I is what? I is your identity matrix. So 1 0 0 1 and minus A. So this will be 1 minus 0. Minus means this becomes plus. Then 0 minus 10 alpha by 2 and 0 minus 1 minus 0, so 1. Okay, this is your I minus A. You have to multiply with this matrix. Multiplying, you will get 1 into cos alpha, 10 alpha into sin alpha. Okay, then next is 1 into this minus sin alpha, then 10 alpha by 2 into cos alpha, then minus 10 alpha by 2 into cos alpha plus sin alpha. Then minus into minus plus cos alpha. Okay. Now you have to make use of identities. Okay. So taking cos alpha, okay, you have to substitute cos alpha as you have to use half angle formulas. Okay. Cos alpha you can substitute as 1 minus 2 sin square alpha by 2. Okay. Why half angle? Because this tan alpha by 2 is given, that is this is your half angle. Okay, so we need all this terms in terms of half angle. Okay, similarly you can write your sin alpha as 2 times sin alpha by 2 into cos alpha by 2, and then your tan alpha by 2. Okay, now for the second term. Okay, again convert this sin alpha. So sin alpha we can write 2 sin alpha by 2 into cos alpha by 2, right? Plus tan alpha by 2 you have to write as it is. You have to convert cos alpha. So cos alpha here you can write it as 2 cos square alpha by 2 minus 1. So this you should remember the half angle formulas. I'll write here half angle formulas first. Okay, so sin 2 alpha, okay, sin 2 alpha is 2 sin alpha into cos alpha. This is your trigonometric identity, right? So when you take half angle you will get 2 sin alpha by 2 cos alpha by 2. Okay, second one is cos 2 alpha. Cos 2 alpha can be written as 1 minus 2 sin square alpha. So taking half angle we will get 1 minus 2 sin square alpha by 2. Then we can also write this cos 2 alpha in terms of cos, that is 2 cos square alpha minus 1. Okay, taking half angle you will get cos alpha equal to 2 cos square alpha by 2 minus 1. Okay, so we have to use all these three trigonometric identities. Okay, moving on to our third element. Okay, again here you have to substitute cos alpha in terms of 2 cos square alpha by 2 minus 1. So this becomes minus square alpha by 2 minus 1 into tan alpha by 2, and your sin alpha you have to take 2 sin alpha by 2 into cos alpha by 2. Okay, next is fourth thing, that is you have to substitute here sin alpha. Okay, sin alpha that is 2 sin alpha by 2 into cos alpha by 2. Okay, and plus cos alpha you can write 1 minus 2 sin square alpha by 2. Okay, now you have to cancel the elements. Okay. Here you can see that tan alpha can be written as sin upon cos, right? So cos and cos gets cancelled and you will get here sin into sin, which is sin square alpha by 2, right? So next is 1 minus 2 sin square alpha by 2 plus 2 sin square alpha by 2. Okay, Here also you can write, you can take this inside, that is 2 cos square alpha by 2 into tan alpha by 2. Okay, so your this tan alpha by 2 will be sine upon cos, right? So cos and cos, one of the cos gets cancelled and you will get here minus 2 sine alpha by 2 into cos alpha by 2 plus 2 into sine alpha by 2 upon cos alpha by 2 into 2 cos square alpha by 2 minus tan alpha by 2. Next is your third term. Okay, so you have to multiply this minus 2 cos square alpha by 2 with tan alpha by 2. So I'll write here minus 2 cos square alpha by 2 into tan alpha by 2, which I can write sin alpha by 2 upon cos alpha by 2. Okay, then minus into minus plus tan alpha by 2 plus 2 sine alpha by 2 into cos alpha by 2. Okay, then here you will get the term same as the first term. Okay, that is tan alpha by 2, you can write sine upon cos, cos and cos gets cancelled, so you will get 2 sine square alpha by 2 plus 1 minus 2 sine square alpha by 2. So this terms can cancel. Here also can cancel these terms, so we will get here 2 cos alpha sine alpha by 2, which is same as this term, so this and this whole term gets cancelled. Again this and this term also gets cancelled, so last answer you will get 1 tan alpha by 2 minus tan alpha by 2, and this is 1, and if you add I plus a you will get the same thing. Okay.